Welcome! In this session, I want you to have a basic foundation in central tendency and talk a bit about parametric and non-parametric concepts and tests. Central tendency is basically the central value for probability distribution. The common ways of measuring central tendency are mean and median. How you would calculate mean is by adding all the values in a variable together and dividing it by the total number of values. The median, on the other hand, is the value at the middle position in the data if the data were arranged from smallest to largest, or vice versa. In general, a data distribution is graphed with the frequency on one side and the actual values of the data, called the continuous values, on the bottom. For example, the continuous values at the bottom could represent weight. Now, how tall the graph is shows the total number of people or subjects who have that weight. An outlier is an observation that is numerically distant from the rest of the data. And you can see in these three graphs that the outliers would be here, because the bulk of the data is here in graph A. In graph B, we see the bulk of the data is in the middle, so the outliers would be at the far ends on either side. On the last graph, the outliers would be on the right side, because the bulk of the data seems to be toward the left. The first graph is negatively skewed. The middle is called normal, and the right is a positively skewed graph. You don't need to memorize everything here so precisely and so fast, but I do want you to see that in a normal distribution, the mean, median, and mode are ideally the same. All three in this case would be great for measuring centrality because all three are right in the middle. However, once you look on the skewed graphs at either side, you see that the mean is very sensitive to outliers. I've circled the means in red in the first graph, the second graph, and the third distribution, and you can see the outliers are almost pulling the mean toward the tail. However, you can also see that the median in each graph is more central than the mean. Thus, depending on the shape of your distribution, you should compare centrality using means or medians. Here's another look at the normal distribution. Assuming that the distribution is close to normal, we can assume that 68% of data fall within one standard deviation, or SD, of the mean. Now remember, the mean in a normal distribution is in the middle, and over here, these numbers represent what are called standard deviations. If you are at 0 standard deviations from the mean, you are at the mean, because the standard deviation is just another measurement for quote-unquote spread from the mean. How spread out are the data? Thus, mean and standard deviation really go hand in hand together. And as you can see, 95% of the data fall within 2 standard deviations, and lastly, 99% of the data fall within 3 standard deviations. Now we can introduce the concept of parametric and non-parametric. In statistics, parameters refer to the mean and standard deviation of the population. We also note that the mean captures centrality in a normal distribution. Thus, a normal distribution is parametric because mean is one of the parameters in the statistics of your true population. And it makes sense to say that tests that compare means are called parametric tests. But by default then, non-parametric tests compare medians. Here are just 4 statistical tests with their commands listed in parentheses. The parametric test comparing the means of 2 groups is called a t-test. Comparing 3 groups is called an ANOVA test. The non-parametric version of the t-test is called the Wilcoxon-Rank sum test. The non-parametric ANOVA is called the Kruskal-Wallis test. Speak with your research mentor about what tests you should be using for your research. Again, this is certainly not an exhaustive list of tests, but just an introduction to parametric and non-parametric tests. This concludes the tutorial on Stata.